Hey folks, got a discussion about relative motion, which is going to involve vectors. So hopefully you've brushed up on your vector addition and subtraction. And I've got a real quick thing here on the left. Let's say you got two objects moving. For the sake of argument, let's say it's two soccer players in a soccer field. And one is moving to the right at VA is 10, and probably a good unit here would be miles per hour, and then VB would be negative 10 I hat miles per hour. Okay. And the first question I'm going to ask is what is the velocity of A? So I'll kind of write this out. What is the velocity of A relative? Oops, sorry about that. Relative to B. So if you were in B's world, what is the velocity of A with respect to B? Another way to write that is what's the velocity of A with respect to B? Okay. Well, if you imagine a short time later, they're like this, right? Okay. And B has moved a distance, and A has moved, in this case, that same distance away from B. So like if A is moving at 10 miles per hour, to B, it looks like they're moving 20 miles per hour because they've gone twice as far relative to B than A has gone relative to the ground. Okay. Now, in other words, if B was your world and you were standing on B, how fast does A look like they're going? Well, it looks like they're going 20, miles per hour to the right. Okay. Now, how do you figure that out mathematically? Well, it's very simple. Okay. So for VA, we're going to write that as V of A with respect to the ground. So VA sub G. And this would be VB with respect to the ground. Okay. To find the velocity of A with respect to B, all you do is you take VA minus VB. Okay. And what that would look like with these fractions here, you would say VA with respect to the ground minus VB with respect to the ground. Okay. Now, with the little subscripts, okay, what you do is it's A over G, that little A over G, and then when you do minus, that's like dividing by, okay, B over G. Okay, so that's what you do with the subscripts. Now, the thing I'm going to show you right now, you don't really have to do, but it's kind of a neat little trick. So then you got A with respect to G, and then this would be the same as times G with respect to B, and the G's cancel out, and you get A with respect to B, which is what we're asking. What's the velocity of A with respect to B? And if we plug our numbers in here, it's 10 I hat minus negative 10 I hat, and you get 20 I hat. In other words, it looks like A is traveling at 20 miles per hour with respect to B. In other words, A is moving at a rate of 20 miles per hour away from B, because that's because B is moving too. Now, what if we get a more of a 2D kind of thing here? So what if A is moving to the right at 10 I hat, and what if B is moving up at 10 J hat? Okay. Same question, okay? What's the velocity of A with respect to B, okay? Well, you're going to subtract, so you're going to take VA minus VB again, and it's going to be 10 I hat minus 10 J hat, whatever, miles per hour. In other words, if you are B, okay, a short time later you are here, it looks to you like A went down, okay? But A also went to the right, so it looks to you like A went right. Okay, so that's the velocity of A with respect to B. Now, if you were finding the velocity of B with respect to A, you would just reverse the process. You would do VB minus VA. Okay. Now, the last one I'll do here, and I'm not going to do all the numbers with this because I'm going to assume that you folks listening to this can add and subtract vectors. But this is a little tweak on this stuff. Let's say you've got a plane moving in the air. And let's say here is the velocity vector of the plane, and it's the velocity of the plane with respect to the air. And let's say this angle here, just for the sake of argument, is 30 degrees. And let's say this is 300 miles per hour. Okay? So if you were the pilot of the plane, okay, your airspeed indicator would say 300 miles per hour, and your compass would say 30 degrees. This is which way you're pointing the plane. This is how fast you're moving with respect to the air. Okay, so your compass would say 30 degrees, and the plane would be in the airspeed indicator would say 300 miles per hour. However, what if you were flying in a wind? And to keep this simple, let's say the wind is going due east or to the right, and that's the velocity of the air with respect to the ground. Okay, and just for the sake of argument, let's say that's 75 miles per hour. You're up in the jet stream somewhere. Okay. What is the velocity of the plane with respect to the air? Or, I'm sorry, to the ground. What is the velocity of the plane with respect to the ground? In other words, if we on the ground are looking up at this pilot, what does it look like they're doing with respect to us? Okay. Well, in this case, you're going to add, because look at the fractions. You got P over A and you got A over G. Well, if you take P over A times A over G, the A's drop out and you get plane with respect to the ground. So in this case, you're going to add. So you're going to take velocity of the plane with respect to the air plus velocity of the air with respect to the ground, and that will give you the velocity of the plane with respect to the ground. Okay. In other words, for us on the ground, we look up the pilot. This is what we're going to see. Now, I'm not going to do all the math here, but I will sketch this out. Okay. So you would add these vectors tip to tail. So here's the velocity of the plane with respect to the air. And here's the velocity of the air with respect to the ground. And the result would be this blue arrow I'm drawing, and that would be the velocity of the plane with respect to the ground. Some things you would note in this example, if you did the math and found the length of that blue arrow, is going to be longer than 300. In other words, the plane's getting a little push from behind, so it's going a little faster than 300. And the angle that they're actually moving at is less than 30 degrees. This angle here would be 30 degrees. So this angle here has to be less. So even though the pilot's compass is going to say 30 degrees, they're not going 30 degrees north of east. They're going something considerably less than that. Okay. And you may have noticed this if you've ever been underneath a plane while it's traveling in the wind and the wind's going sideways to it some. You'll notice the plane is often kind of flying into the wind a little bit. It's kind of sliding along. Okay. The same thing happens with the boat in water, and that's going to be the next example I'll do in the next video is a boat in water. So I hope this was a good intro for you, and thank you very much.